Hi, I'm Farah. Welcome to my channel. We're gonna set up and calibrate OptiTrack. So this is the OptiTrack camera. This camera is connected to the truss, which is a structure we have with this clamp. It also has to be connected via Ethernet using the purple cables that are connected to the OptiTrack switch, and it is an infrared camera. First, we need to turn on the OptiTrack switch by pressing here, turning on the smart plug connected to it, and you will hear that sound, which is boom, which means that it turned on. This is Gaia, the computer for OptiTrack. From there, you can open Motive 3D, which is the software for OptiTrack. Once you open it, the camera turns blue, and Gaia acts as a bridge between the OptiTrack network and our network, so it has both Ethernet cables connected, 1 and 2. In the Motive 3D software, you can see here all the cameras, and here you have a layout of each camera. In there you can see, for example, here all the markers and all the markers that we decided to exclude also. Also, when you right click on a camera, you can change the video type to, for example, grayscale, which shows you actually what's it's showing. Pressing F zooms into that camera, and Shift F zooms back out. So that will help us orient the cameras so we can get the most coverage. When you select the camera turns yellow to tell you that that camera is selected. And depending on the video type you put, the camera will turn on different colors. So for object and precision, the camera will be blue. And then for grayscale and MJPEG, it will be red. So we go camera by camera and we rotate and orient them to try to get as much coverage. We turned off the lights, closed the curtains, and remove any obstructions to try to see better. We modify the exposure and gain to try to get better results. You press new calibration, and now you see that there are visible objects detected. But before we start, first thing we do is we select all the cameras. So clear masks. After you clear, what you do next is you have to remove any objects visible. So that could be, for example, if this is visible in the camera, then the calibration won't work. Remove any marker that we know is a marker from the views of the cameras, and then we will mask it again. You need to put all the cameras in object mode, which is, again, just this video type object. And here that will tell you which cameras still have markers detected. So as you can see, camera 2 is detecting the thrust, the actual truss, as infrared. So now what we do is we will go back, select all the cameras, and then we will do mask, and then continue. So this is the same camera that we were talking about that was seeing the thrust as objects. And as you see now, after we mask it, they turn red, meaning that they're masked and they will not be detected. So the next step is wanding. What wanding is just moving this stick in an infinity sign across the entire space. And now when I start, you can see that it collects samples per camera. So it's how many times each camera has seen this. And we need around 3,000, more than 3,000 preferably, samples per camera so we can consider it fully calibrated. So as you can see, this camera has a light on it, and when you wand next to it, it starts to fill up, and that tells you basically how much you've completed of the calibration for this specific camera. When we have enough samples, like we do here, so you see the minimum sample is 3,000, which is good enough for us. We press start calculating. So now that we calibrated the cameras, the last thing left to do is to tell them where the origin is, because they don't know that right now. So we use this triangle, we place it on the origin that we want, and that's what we do in this step, which is set the ground plane. We place this here, just try to push it against the foam and line it up with this tape. That way it's always the same and we don't have issues with positions being different from calibration to another. Just press set ground plane, and that sets our ground plane. And now we are basically done.
Okay, now is when it gets tricky, and is that OptiTrack use the right hand law for the axes, and with the Y axis pointing up. Okay, this is different from ROS, Blender and other software that has the set pointing up. Okay, so Motif will do a transformation from Y pointing up to set pointing up. That means it will rotate in a way that set now will be pointing up with the X pointing in that direction and Y pointing in that direction. Okay, let's get back to the beginning. With the ground plane marker, we have the small edge being the X and the long edge being the set, Y pointing up, and we want to trick it in a way that when it's converted to set pointing up, we get the X in this direction and Y in that direction. Okay, in order to do that, we have to rotate the Y axis minus 90 degrees. Okay, that means from X to set 90 degrees, and then when the software is sending us the values, we'll send it with the set pointing up, so the software will rotate another 90 degrees in X. So by the end we will get Y in that direction, X in this direction being this 0, 0, and the set pointing up.
Now that we've placed it, so now we go to the third page, and now we can see how we can translate and rotate it. So we will do a rotation of minus 90. Oh, bomb. Apply. So, and as you can see here, it already has switched, which is perfect. And now we can click done. So now the last thing we have to do is go to edit, then settings, and that's what we talked about. So we need to change the up axis from Y to Z, and then we are done. Congrats.